Welcome to the Deep Dive, where we cut through the noise to get you well-informed, fast. Today, we're diving into something that, well, it can feel a bit daunting for developers, especially if you're just starting out. Local development with Kubernetes. Now, Kubernetes, it's this incredibly powerful system, right, for automating deployment, scaling, managing containerized apps. Hugely powerful. But getting it to actually run smoothly on your own machine, that could be a real challenge. So the big question for you, the listener, is this. How do you actually test and iterate on your Kubernetes applications without fighting complex setups all the time, or watching cloud bills creep up just for debugging? Our mission today is to unpack three really key tools that change this whole game: Minikube, Kind, and Tilt. Think of these as your shortcut, really, to getting up to speed with an efficient local Kubernetes workflow, tailored specifically for you.
And the why here is so important. Kubernetes at its core is built for these huge production-scale distributed systems. Trying to mimic that whole thing locally, it used to be, well, frankly, overwhelming. These tools are not just making it easier, they're shifting how you develop. You're not waiting ages for a remote deploy anymore or getting tangled in setup nightmares. Instead, you're iterating on your code almost instantly. It turns this cumbersome, costly, slow process into something fluid, fast, and cheap right there on your laptop. And that immediate feedback, that's where the real speed and innovation comes from.
Okay, so what I'm hearing is these tools basically smooth out all those friction points, the things that made Kubernetes development feel so intimidating before. All right, let's unpack this. How do they actually solve these problems? Before we had Minikube, Kind, and Tilt. I mean, local Kubernetes development almost felt like a contradiction in terms. What were those specific pain points? What were developers really struggling with just to get code running in anything like a Kubernetes environment? I sort of remember feeling like you needed a PhD in virtualization just to begin.
Oh, you're spot on. It was a totally different world, really full of hurdles. First off, complex cluster setup. That was massive. Just getting any Kubernetes cluster running locally needed serious expertise. You were juggling multiple tools, needed a powerful machine. For beginners, almost impossible, just completely inaccessible. Then, the slow feedback loops. If you had to push every little code change to some remote cluster to test it, it was just inherently slow. And often expensive, too. Deploy, wait, find a bug, fix, deploy, wait, again.
Yeah, it kills productivity.
Totally, just drag down the whole development cycle. And resource constraints were a big one. Real Kubernetes needs beefy hardware or cloud resources. Most local machines just couldn't handle it, or it wasn't practical, cost-wise too. Plus, you had all these manual deployment processes. People were building images, deploying Kubernetes stuff by hand. So time-consuming and incredibly easy to make mistakes. And the final killer, environment disparity. You'd fix bugs locally, deploy, and then bam. New bugs pop up only in the remote cluster because things were just different.
Right, the classic works on my machine problem, but for Kubernetes.
Exactly. So what's really neat, what's fascinating, is how these tools, Minikube, Kind, Tilt, they just zero in on those exact pain points. They offer lightweight, automated, really developer-friendly solutions right on your own machine.
Okay, so knowing those hurdles, let's see how these tools actually step up. Let's start with Minikube. What exactly is Minikube? Why is it so often the first thing people recommend when you're new to Kubernetes?
Right. Minikube is an open source tool, and its whole job is to run a simple single-node Kubernetes cluster locally on your machine. Its main goal is really to give you a straightforward, kind of all-in-one way to experience Kubernetes without a massive setup headache. It's very beginner-friendly. It mimics a production cluster, just scaled down, so it's perfect for learning the ropes, testing basic configurations, maybe developing a simple app without touching the cloud. Think of it like training wheels for local Kubernetes, which honestly most of us need when starting out.
Training wheels. I like that. So how does it work under the hood, conceptually? Does it just spin up a cluster out of thin air?
Not quite magic, but it's clever. It creates this lightweight Kubernetes cluster either inside a virtual machine, think VirtualBox, or similar, or it can use a container runtime you might already have installed, like Docker or Podman, things that actually run your containers. It bundles all the core Kubernetes parts, the API, server, scheduler, controllers, all into that single node. So you get a simulated but functional cluster. And you talk to it using Kubecle, the standard command line tool, same as you would with a real cluster. It also supports add-ons, things like a Ingress controller or the Kubernetes dashboard, so you can play with those features too. And importantly, you can point your local Docker daemon at it, essentially, to deploy images you build locally directly into Minikube.
Okay, that sounds ideal for learning the basics. Makes perfect sense. But let's talk limitations. Being single node, where does that start to pinch? When would you, as a developer, start thinking, okay, I need more than Minikube?
Yeah, that's the key trade-off. Minikube is fantastic for getting your feet wet, but because it is just one node, it can't fully replicate the distributed nature of a real-world Kubernetes cluster. So if your application depends on services running across different nodes, or if you need to test complex networking setups, maybe high availability, Minikube's limitations will become apparent pretty quickly. You just can't simulate those multi-node interactions. And that's exactly where something like Kind comes into the picture.
Perfect transition. So, Kind, what's the story there? How does it use Docker containers to give us that multi-node experience?
So Kind stands for Kubernetes in Docker. That name tells you a lot. It's a tool specifically designed to run Kubernetes clusters using Docker containers as the nodes themselves. So while Minikube often defaults to a VM, Kind uses Docker directly to simulate each node in your cluster control plane node, worker nodes, etc. It's really built for testing Kubernetes itself or applications on Kubernetes in a very lightweight and reproducible fashion.
Okay, Kubernetes in Docker. If someone's already using Docker day to day, does Kind feel like a natural next step? Is it easier to get going with, or are there different complexities?
For folks comfortable with Docker, yeah, it kind of often feels very intuitive. It plugs right into that workflow. The main complexity, and it's not much, is just defining your cluster setup in a simple config file. You say, I want 3 nodes, or use this specific Kubernetes version, but the payoff is huge. Because each node is just a container, Kind clusters spin up incredibly fast and tear down just as fast.
So speed is a big factor.
Definitely. This makes it fantastic for developers needing those multi-node setups for testing more complex apps. And it's especially brilliant for CI/CD pipelines, automated testing where you need a clean, reproducible cluster for every test run. Kind is perfect for that. You still use kubectl to interact with it. And like Minikube, you can load your locally built container images directly into the Kind cluster nodes, which again, really speeds up development.
So, bringing it back to you, the listener, what's the concrete advantage of Kind over Minikube when you're maybe building something more complex, like microservices?
The big win with Kind is getting that lightweight multi-node Kubernetes cluster locally. This lets you experiment with much more complex application architectures. Think microservices, right?
Yeah.
Where different parts need to run on separate simulated nodes and talk to each other. Kind lets you test that interaction realistically, see how components behave across nodes, all without needing heavy VMs or cloud resources. So yeah, testing a microservices app with, say, 3 nodes locally to make sure everything connects properly before production. Kind is your tool.
Okay, that makes sense. So we have Minikube for starting out, Kind for multi-node testing, but we still need to get our code into these clusters efficiently. That constant cycle of build, push, deploy, that's where Tilt fits in, right? To automate that development loop. What exactly is Tilt?
Exactly. Tilt is all about that inner development loop. It's another open source tool, but its focus is squarely on automating and optimizing the workflow of developing Kubernetes applications. What it does, basically, is watch your code files. When you save a change, Tilt automatically rebuilds your container image and then deploys that update to your local Kubernetes cluster. Whether that cluster is Minikube or Kind or something else, it streamlines that whole code-to-cluster process.
Okay, automatic rebuilds and deploys. That sounds like a huge time saver.
Yeah.
But is it complicated to set up? If I'm just getting started with Minikube or Kind, is adding Tilt another steep learning curve?
It's actually surprisingly approachable, and the benefit is immediate. Tilt isn't just saving you time, it's freeing up your mental energy. It handles all the tedious mechanics of getting your code running in Kubernetes, so you can just focus on coding and debugging your actual application, not fighting the deployment process. You define how Tilt should build and deploy your services in a file called a Tilt file. It's written in a language called Starlark, which is like a simplified Python. Pretty easy to pick up. So Tilt's watches your source code, watches your Kubernetes YAML files. When anything changes, it triggers the rebuild and update in your cluster. And it's smart. It can do things like live updates, where it syncs code changes directly into running containers without a full image rebuild and pod restart. That makes iteration incredibly fast.
Wow, okay, live updates sound amazing.
They really are. Tilt integrates smoothly with Minikube and Kind, naturally, but also with tools like Helm or Customize if you're using those for managing your Kubernetes configurations. Plus, it gives you this really nice web UI. You can see the status of all your services, see logs streaming in, view errors. It makes debugging way easier, especially when you have multiple services.
So Tilt basically takes over that repetitive loop, letting you see changes almost instantly.
Oh.
For a beginner, that must remove a lot of the perceived complexity of Kubernetes day-to-day development.
Absolutely. It makes that iteration cycle so much faster and less error-prone. You save a change, Tilt does the work, you see the result, quickly. Beginners can iterate rapidly without needing to become cubectl wizards just to see their changes. This is really where productivity skyrockets. It gets genuinely interesting here.
Okay, so we have these three tools. Minikube, our single-node starter. Kind, for flexible multi-node setups in Docker. And Tilt, automating the whole workflow, pulling it all together then.
What does this mean for your workflow? How do you decide which tool or combination of tools to use when? Right? Boils down to matching the tool to your specific need at that moment. You'll want Minikube when. You're first learning Kubernetes concepts, you need a simple single node cluster for basic tests, or you just want that all-in-one easy setup. Learning about deployment services, maybe trying out an add-on like the dashboard. Minikube is perfect for that initial exploration. Deploying a simple first app, Minikube. You'll look towards kind when. Your application needs multiple nodes, maybe you're testing complex configurations like network policies, or you need clusters for CI/CD and automated testing. Its lightweight, Docker-based nature makes it great for reproducibility. So testing that microservices app across several nodes, that's a kind use case. And you'll bring in Tilt when. Your primary focus is rapid development speed. You want that automated build and deploy cycle, the fast feedback loop with live updates. Maybe you're working on a complex app with many moving parts, so actively developing a web app, making frequent code changes, and wanting to see updates instantly without manual steps. That's Tilt's sweet spot.
And the real power comes from combining them, doesn't it? Creating that seamless flow. Can you walk us through a typical combined workflow?
Absolutely. The most common and arguably most effective workflow looks like this. First, you use either Minikube or Kind to spin up your local Kubernetes cluster. The choice, again, depends on whether you need single-node simplicity, Minikube, or multi-node realism Kind. Once your cluster is running, you bring Tilt into the mix. You write your Tilt file telling Tilt how to build your app's container images and how to deploy them using your Kubernetes manifests. Then Tilt takes over, it watches your code, you make a change, save the file, Tilt automatically rebuilds the necessary image and updates the deployment in your chosen cluster Minikube or Kind. You see the changes reflected very quickly, often through the Tilt UI.
So let's picture it. You, the developer, start your day, maybe run Kind, create cluster, then you run Tilt up. From that point on, you're just in your code editor. Save a file, Tilt handles the build, and deploy to Kind automatically. You're focused purely on the application logic.
Exactly. That's the goal. It transforms local Kubernetes development from this series of manual, potentially slow steps into a fluid, almost background process. It makes it feel much more like traditional local development, just Kubernetes power behind it.
What a fantastic overview. It really clarifies how Minikube, Kind, and Tilt fit together to solve real problems. So to recap for everyone listening, these aren't just abstract tools. They are essential pieces of the puzzle for making local Kubernetes development practical, accessible, and efficient, especially if you're starting out. They directly attack those big pain points, the setup complexity, the slow iteration cycles, the resource demands.
And it really lays out a clear learning progression for you. Start with Minikube, get comfortable with the basics. When you need more complex scenarios, transition to Kind for that multi-node testing capability. And then, to really boost your day-to-day productivity, integrate Tilt for that rapid automated development workflow. Put together, these tools create a really powerful yet approachable development environment right on your own computer. And maybe here's a final thought to consider. In a world where cloud development environments can get really complex, maybe even a bit unwieldy, how much more of an edge do you gain when you master tools that give you this level of control, this kind of rapid feedback locally? Think about the innovation that's possible when you can iterate on complex distributed systems almost instantaneously, right on your own machine. The possibilities are pretty exciting.
That's a really compelling thought, the power of that instant feedback loop. Thank you for joining us on this deep dive. We really hope this helps you explore Minikube, Kind, and Tilt and see how they can supercharge your own Kubernetes development journey.